This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Learn the concept of potential energy. So before understanding this concept, we just see one example that if we throw a ball with some initial velocity u, then it moves upward and its velocity starts decreasing. So its velocity at any point will be less than u. As the velocity is the less, so its kinetic energy is also less. So kinetic energy at any time will be less than the kinetic energy which was thrown at the starting of the point. So the kinetic energy at the time t is equal to 0 when the ball was thrown was the highest. After some period of time it eventually stops and the velocity is equal to 0. So we have seen this kind of phenomena in our day-to-day life. So as the kinetic energy decreases, so it must be converted into some other form of energy as per the conservation of energy, and this energy is called as potential energy. So kinetic energy at any point is converted into potential energy, and potential energy is associated with the position. So in a space occupied by conservative force, every point is associated with certain energy which is called as the energy of position or potential energy. So first concept is that the potential energy is defined only for the conservative forces, and second is that the potential energy is fixed for a particular position. So if we consider a position equal to height h, then the potential energy in case of gravity will be given by mgh. So how this value of mgh comes? Basically, if we consider a conservative force, then the work done against the conservative force will be stored in some kind of energy, and this energy we call as a potential energy. In case of gravity, we call it as a gravitational potential energy. Like if you see this figure, then if we throw a ball upward, then the work will be done against the gravity. The gravity pulls this ball in the downward direction and ball moves in the upward direction. If the ball, let's say, moves by a distance equal to h, then the work done against the gravity, which we denote it by minus wg sign. So it is equal to m into g into h. It is the force done by gravity and it is the displacement. So work done against the gravity is equal to mgh, and it is stored in form of potential energy. So clearly the work done against the conservative force will be stored in kind of energy, and this energy is called as potential energy. So we may write that the work done against conservative force is stored as potential energy. So potential energy generally is of three types. First is elastic potential energy, electric potential energy, and gravitational potential energy. We will read about all these things separately in each section. Now, what is this change in potential energy? So change in potential energy between 2 points is defined in terms of work done by the associated conservative force in displacing the particle between these 2 points without any change in kinetic energy. So consider this body which is at some height h, and this body will move downward direction. So first thing is that the gravity or the conservative force mg acts in the downward direction. It just move the body in the downward direction. Now you have to you have to make sure that there must not be any change in the kinetic energy, as the body is moving with a zero velocity. So body is moving very slowly to reach this point, and in this case whatever will be the change in potential energy, we it is defined as in terms of, suppose this is our second point and this is our first point, then in terms of potential energy it is defined as u2 minus u1 is equal to minus f dot dr in, and the limit will be r1 to r2. So what is the significance of this formula? Like here it says that if the force acts which moves the body in the which moves the body, then the work done by that conservative force will be changed into the potential energy. So change in potential energy is equal to work done by that conservative force. If the object moves uh, along the conservative force, then the potential energy decreases, and if the object moves against the conservative force, then the potential energy increases. So why this negative sign comes? This negative sign is due to if work done against conservative, then potential energy increases. So here if you see we are doing work done against, then potential energy increases, so that's why this negative sign comes. And if I say that work done in direction of conservative force, then potential energy decreases. Like if the mg acts in the down if the body moves in the downward direction, then the work done by mg will be the positive, and correspondingly the potential energy decreases, and the potential energy of the point 2 will be less than the potential energy of the point 1. So clearly it must be clear to you for why this negative sign comes. In fact, we can prove this as per the work energy theorem also, that the work done by the body or work done by any conservative force plus some value or the some let's say delta u is equal to delta kinetic energy. So as we know that the work done by the conservative force will be equal to change in kinetic energy as per the work energy theorem. So clearly as we are making the kinetic energy equal to 0, that is there without any change in the kinetic energy, so the right hand side will be 0, and in this way we just write that work done by the conservative force is equal to change in potential energy with a negative sign. So I think this formula is clear to you, that the change in potential energy will be equal to minus of work done by the conservative force, and the value is, or if the force or the value of conservative force is not constant. If the force will be constant, we just straight away take the force outside. Like in case of mg, we know that it is constant and the value is equal to minus mg into limit r1 to r2 dr, and the value is equal to it's equal to minus mg into h as per this figure. But if the force is not constant, then we have to use the concept of calculus, and this formula will be very handy at that time. That is u2 minus u1 is equal to minus r1 r2 fr dr, and is equal to minus w. So how we define unique value to potential energy at any point. So till now we are talking that change in potential energy, but how we define the unique value of potential energy at any point. So for this we just need a reference point. So by assigning some arbitrary value to a fixed point called reference point, we just define the potential energy at the unique point. Like in case of gravitational potential energy, we just consider potential energy at the ground is equal to 0. and although it is not zero, but we just consider the potential energy will be equal to zero at the ground, and it serves as a reference point. So similarly, you for any conservative force, we just take reference point at infinite or at infinity, and potential energy to be zero there. So as we know that u2 minus u1 is equal to minus r1 to r2 f dot dr, and it is equal to minus w. So we just take our r2 is equal to, or in fact we just take r1 is equal to infinity. So suppose this is the object which is have to move under this conservative force. So this is a conservative force, and the object have to move under this force. So you have to define the potential energy for this point, which is, this is basically the center of force. So you have to define the potential energy at the center of force, or at a r distance from the center of force. So what you will do, you just define that in such a way that the object is moving from the infinity, and it has to be moved up to this point, which is at r distance from the center of point. So basically our first point is r1 is equal to infinity, and r2 is equal to r, and at the infinity we just consider potential energy u1 is equal to 0, and here our potential energy is equal to u2 is equal to u. So we just use this concept that r1 is equal to infinity, so the potential energy will be changed from u2 will be changed to u, and we just write u minus 0 as at the u1 is equal to 0 at the infinity. So u1 minus 0 minus infinity into r f dot dr, and it is equal to minus w. So basically it's a negative of work done. So it's a negative of work done when we move the object from infinity of to the point r. So I think this is clear to you. So now we will next learn next concept, that relation between potential energy and work done in the conservative force. So in case of conservative force, potential energy is equal to negative of work done in shifting the body from reference point to the given position. So it is clear, and if the particle moves opposite to the field, then the work done by the field will be negative, and so change in the potential energy will be positive. So as the potential energy is equal to negative of work, so the potential energy or the change in potential energy is equal to negative of work. So if the particle moves opposite to the field, then delta u will be positive. So if the particle moves opposite to field, then work done by field will be negative, and delta u will be the positive. So I just note down that the particle opposite to field, what it means, w is less than 0 and delta u is greater than 0. Similarly, when w is greater than 0, that is if the particle moves in the direction of field, then the work done will be positive, and delta u will be less than 0, and the potential energy will decrease.